All right, let's jump straight into this explainer because today we are going to completely transform your workflow. Look, if you're a developer, a QA engineer, or honestly anyone who touches APIs, you've definitely felt the pain of deploying a new feature and then spending hours agonizingly clicking through the exact same API endpoints just to make sure nothing broke. It's tedious, it's exhausting, and let's be real, it absolutely kills your productivity. But today, we're ditching manual testing entirely. We're going to build robust, automated API checks right inside Postman, turning hours of mind-numbing, repetitive work into a process that literally takes seconds.
When you stack these two approaches side by side, the contrast is just stark. Manual clicking fundamentally relies on human memory and patience. That means it's incredibly slow, inherently repetitive, and highly prone to human error, especially when you're fatigued at the tail end of a long release cycle. Automated scripts completely flip that dynamic. By letting Postman's JavaScript engine do all the heavy lifting, your testing becomes infinitely scalable and lightning fast. And most importantly, it gives you a highly reliable safety net that executes exactly the same way, whether it's your first cup of coffee on a Monday morning or your 100th deployment late on a Friday night. So here's our roadmap for today. We'll kick things off with a quick intro to test scripts, then move step by step through asserting status codes, validating response bodies, and checking response times. Once our script is totally bulletproof, we'll automate the entire flow with the collection runner and wrap up with a high-stakes hotfix scenario.
Section 1. Intro to Test Scripts. We'll be using the JSON placeholder API for our foundation today.
Section 2. Asserting status codes. This is our very first absolutely crucial validation point.
So for our testing round today, we're using the free JSON placeholder API. When you open a request in Postman, right under the URL bar, you'll see a Tests tab. Now, the very first check in any API contract is always the HTTP status code. Before we even look at the data, we have to ask, did the server even understand us? To verify this, we use the pm.test function. This is Postman's built-in JavaScript method that gives you a nice, isolated environment to write your assertions. And the best part is, you don't need to be a senior backend engineer to use it. Postman designed this function to be incredibly approachable so anyone can verify server responses with just a basic grasp of logic. Look at how elegant and simple this JavaScript snippet actually is. We start by calling pm.test. We pass it a descriptive, human-readable name, something like status code is 200, and then we provide a function. Inside that function sits our actual assertion, saying we expect the response to have a status of 200. It reads almost exactly like plain English, right? This single line of code acts like a digital bouncer, guaranteeing that your server is returning an OK success state before you proceed any further.
Once you've got that snippet written, the execution flow is entirely seamless. Step 1, you hit send to trigger the API call. Step 2, Postman immediately runs your script against the data bouncing back from the server. And step 3, you instantly view your results. Instead of you manually scanning raw JSON headers trying to spot a sneaky 404 or 500 error, you get the immediate psychological win of a green pass, or the critical, unmissable warning of a red fail. This instant feedback loop is the absolute bedrock of modern API testing. Moving right along to Section 3, Validating Response Bodies, because verifying the status is just the beginning.
So knowing the status code is a great start, but it immediately brings up our next logical question. Is the return data actually correct? A 200 OK is completely useless and frankly pretty dangerous if the API is returning garbage data. Imagine an e-commerce API that returns a perfect 200 success code but delivers an empty shopping cart to the front end, or worse, charges the wrong user account. No way. To prevent these massive false positives, we have to dig past the headers and validate the response body itself.
To ensure our business logic is functioning perfectly, we can just stack more complex validations right inside our test tab. Behind the scenes, Postman lets us parse that raw response into a JSON object. From there, we can drill down into any specific property we want. Using our JSON placeholder API as an example, we can explicitly assert that the returned user ID strictly matches the one we requested. We can verify that a post title string actually exists and isn't null, or we can go all out and validate the entire payload against the strict JSON schema, ensuring no unexpected fields ever slip through the cracks.
Section 4. Checking response times, because speed is a feature. Moving past data integrity, we absolutely have to talk about latency. An API could return a perfect 200 status code with pristine, beautifully formatted JSON, but if it takes 10 seconds to load, your users are going to abandon your application entirely. To prevent this, we write a quick script using pm.expect to assert that our response time stays below a strict threshold. Often 500 milliseconds is a really standard benchmark for snappy microservices. You just write a quick assertion expecting the response time to be below 500. And just like that, you've baked performance testing directly into your functional checks.
When we benchmark performance, it's crucial to set a maximum allowed threshold, like our 500 millisecond limit. Now, while tracking average response times can be somewhat helpful, averages are notoriously easy to skew with outliers. Instead, we want to benchmark using the P95 threshold. This means we are actively testing to ensure that 95% of all user requests experience speeds faster than our 500 millisecond limit. By embedding this exact performance check into our automated tests, we guarantee our applications stay consistently fast for the vast majority of our users.
Section 5. Automating with Collection Runner. It's time to automate these workflows.
Now that we've built a robust multi-layered test checking the status, the body, and the speed of a single endpoint, we need to scale up. Testing one endpoint at a time manually, it just doesn't cut it in a fast-paced, agile environment. Enter the Postman Collection Runner. This tool lets you orchestrate complex workflows effortlessly. You just start by selecting your environment, like your staging or production server. Then, if you're doing data-driven testing, you can actually upload a CSV file packed with hundreds of varying user inputs to run multiple iterations. Click Start Run, and Postman fires off every single request in sequence, totally automatically.
The return on investment for implementing this workflow is just massive. Teams leveraging the collection runner for regression testing report saving an average of 8 to 10 hours a week. Just really let that sink in for a second. By converting repetitive manual verification into an automated one-click suite, you are literally reclaiming an entire workday every single week. It frees you up to actually build new, exciting features instead of just manually verifying the old ones over and over again.
Finally, Section 6, Real-World Hotfix Scenario. Let's see this in action under pressure. Let's ground all this theory into a practical scenario that strikes fear into the heart of any engineering team. A critical Friday afternoon hotfix deployment. Imagine a bug was found in production, you've pushed the code, and these 5 critical endpoints, users, posts, comments, albums, and photos, just went live. The CEO is pacing, customers are waiting, the tension is incredibly high. You need absolute, undeniable certainty that their status codes, response bodies, and latency limits are perfectly intact across the board. You simply cannot afford a single mistake under this kind of pressure.
Now, if you were testing this manually, opening each tab, firing requests, eyeball scanning massive JSON payloads to spot an error, it would take agonizing minutes while the system was potentially still broken. But by clicking one single button on our automated collection, we completely validate all 5 endpoints, run dozens of embedded JavaScript assertions, and secure the entire hotfix deployment in exactly 30 seconds. That is 30 seconds to total peace of mind for you, your team, and your users.
So this explainer has walked you through structuring baseline status checks, expanding those into complex data validations, and ultimately scaling up with the collection runner, so you literally never have to manually test an endpoint again. Which leaves us with one final vital question. With all your API checks running flawlessly on autopilot, what are you going to achieve with the 10 hours of manual work you reclaim every single week? Go write those test scripts, launch that collection runner, and I will catch you in the next explainer.